All right, kids, let's do this review. Now, remember, I'm going to be going fast. So if you need to stop, rewind, look at things again, make sure you use this video for the best possible purposes. All right, if we're looking at a proportion, the way we want to attack it is to cross multiply. 12 times x is 12x. 9 times 16, I think, is 144. So I can solve pretty quickly and find out x is 12. Okay, this is still a proportion, but we don't normally write the ratios like this. So I would actually rewrite this the way I like to see it. Y over 10, 54 over 5y, and now you can cross multiply. Anything times 10, you just add a 0 on it. And then y times 5y is actually 5y squared. I got to get rid of the 5 first. All right. I think that's going to give me, that would be 108 equals y squared, and I would want to square root both sides. Now we'll work on a concept called simplifying radicals next to unit. I could either leave it the square root of 108, or that's about 10.4. Okay. Here, a lot of people are going to make some common mistakes. Not on 4 times 6. That's not so bad. But 3 times m minus 2. Make sure you're distributing the 3 times the m and the negative 2. Then if I add 6 to both sides and divide by 3, m is 10. All right, an architect's model for a building 2.7 meters long to 1.1 meters wide. And you got to remember I put the length on the top and the width on the bottom. So when I finish this proportion, the actual building is 360 meters wide. I need to know if I put the width on the bottom, I got to put this 360 meters down here. Now, the best part about if all the units weren't the same, as long as these two are the same and my other two are the same, you actually don't have to do any unit conversions, which is why proportions are really nice. If we want to know what the length is, that's where my variable is. Again, cross multiply. 2.7 times 360 is 972. Divide both sides by 1.1, and I'm going to get x about equal to 883.6. Sorry about the handwriting there. All right, now we have to determine if the two polygons are similar. So if we're looking at triangles, then I want to probably look at one of those shortcuts, the shortcuts, side, 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 side angle, angle, okay? Now here, I got two options. I do know I have one angle that is equal, so I could go with side, angle, side, or I got all the sides, and I could look at that. I'm going to try and match up my sides. I'm going to compare 30 to 21 and see if that is equal to 20 compared to 14. I made two ratios, so the easy way to see whether those are equals to cross multiply. All right, 21 times 20 is going to be 420. 14 times 30 happens to also be 420. So this does work. I investigated it, and here's my shortcut, since I knew that angle A was the same as angle X. Okay. Now here, I'm comparing these two, so I can't use a shortcut. All right. So then I have to go back to the basics. I need to make sure that every corresponding angle and every corresponding angle has got to be congruent, and every corresponding side has to be proportional. Problem is, I don't know anything about any of the angles, so I'm going to tell you right now, this is going to be a giant no. But let's look at the sides just in case. 13.5 is longer than 9, so I'm going to compare 13.5 to 18, and I'm going to compare 9 to 12. Now, if I cross multiply, I get 162 this way. I get 162 the other way. So a lot of people might be thinking, oh, this is great, but we can't use any shortcuts. I can't use any of these shortcuts with four-sided objects. I don't know anything about the angles. So I can't prove they're similar. They might be, I can't prove it. I would need to know that this angle here was the same as this one, and I can't prove that. Okay. All right, word problem. Leonardo da Vinci's famous portrait, Mona Lisa, is 30 inches tall, 21 inches wide. Let's go ahead and make a ratio. 30 inches tall, 21 inches wide. John, that is postage stamp of Mona Lisa. Similar. So we can make a proportion. All right. The height of the postage stamp is 4 centimeters. So again, we don't have the same units, but we're fine with proportions. All right. Because realistically, and you learn this in chemistry, we have inches divided by inches. We actually don't care about those units. Those units cancel. All right. Height, we put tall on top. So I got to put the 4 centimeters on top. We want to know the width. There's my x. 4 times 21 is 84 equals 30x. 84 divided by 30 is going to be a decimal. Happens to be exactly 2.8. We're doing great. All right, here they're actually asking us to use, these are all triangles, so we can go with these shortcuts to determine if they're similar. Okay, so this can be a little tricky. I do have an angle here and an angle here, and I got some sides, so I'm leaning towards this shortcut. So this is, you gotta be careful. 16 in the big triangle would compare to 12 in the little triangle. All right, the other side, on the other side of the angle, it's not 8 or 24. You got to add them up. That's 32, I guess. And that would compare to 24 in the other triangle. If I cross multiply, 32 times 12 is 384. 16 times 24, 384. This is going to work out. I've got an angle, an included angle in between the sides, and the surrounding sides are proportional. Here, common mistakes possible. Make sure you realize longest side, shortest side, medium one. Make sure you're comparing the longest side to the longest side. Make sure you're comparing the smallest side to the smallest side. And then we can finish it off with 3.5 compared to 2.1. So I can do a lot of cross multiplication, or I can do this crazy calculator trick where I take 6 divided by 3.6, and I can just find out what is the reduced fraction. This is the same thing as 5/3. I can do this real quickly. 3 divided by 1.8, math, enter, enter. Also 5/3. 3.5 divided by 2.1, math, enter, enter. All of those fractions are equal to, remember, this is the similarity ratio. So if I investigated all three ratios, they're all equivalent. We have proportionality. We're good to go here. All right. So here we have a small triangle and a bigger overlapping one. Each of those triangles has a congruent angle. All right. And actually, angle C in the small triangle will certainly be the same as angle C in the big triangle. Remember, that is the reflexive property. So I got the right angles, and I got angle C. There we go. Make sure you're aware of this. Remember, this can be used in a proof. So I'm going to graph the image of this triangle after dilation of 1/2. So the easy way to do this, if I know that S is at -1, 4, all I got to do, if I want to find out where the image of S is, just multiply everything by 1/2. So it should be at -1/2, 2. t was at 3, 2. So I know the image of t, multiply both numbers by 1/2. 1.5, 1. R is at -2, -4. So the image of R, remember, I'm just multiplying all of these numbers by the scale factor. Factor means multiply. -1, -2. So this would be at -1, 2. This would be at 1.5, 1. And -1, -2. There's my new dilated object. Here's a proof. I got triangle ABC. We have perpendicularity from BD to AC. They've already marked the right angle. We want to prove the triangles are similar. So I know that first step, that's that given information. They're saying ADB is a right angle. This is certainly a right angle, definition of perpendicular lines. Well, why would ADB have to be equal 90 degrees? All right, that's the definition of a right angle. All right, they mentioned it here, so we can use it in the proof. Look, they did it again. ABC is 90 degrees, definition of a right angle. I guess that, they said it was a right triangle, ABC. Got it. All right, why do those have to be equal? You can use a bunch of, you could say all right angles are equal, but it's basically, it's a substitution move. We can just take ABC and substitute it right there. Now here's that idea I showed you before. Why does angle A in the small triangle have to be equal to angle A in the big one? We've seen that before. That's the reflexive property. So realize, all right, we have these two angles that are equal and these two angles are equal. Why did the triangles have to be similar? We have two angles. That's the angle-angle similarity shortcut. Okay, here. A tree stops a surveyor from directly measuring the length of a lot. We want to find out what is EF. We want to find X from E to F. Well, I got plenty of sides. I know 18 kind of matches up with X. I just got to pick two other sides, match up. We have a similarity here. I know that this angle is equal to this one. We can check similarity. Actually, 12 smaller than 14.4, so 12 over 20. 14.4 compared to 24. Let's just make sure. 20 times 14.4 and 12 times 24. They're both 288. So we do have similarity. This is a proportion. I'm just going to use one of those to finish this proportion and solve for X. 12X equals 360 divided by 12, and X is 30. We're doing good, kids. We're doing good. All right, I know I got a similarity here. Here, I'm just going to tell you, if they want to find the measure of RU, please just listen to me. I'm going to take the small triangle, and I'm going to take the big triangle. I'm going to split them up. I know I got 10 here, 15 here. But you got to be careful. This whole length, that's what they want to know. I can just call that X. I know part of it's 10, but I don't need that. But I know the longest side here is 15 plus 18, which is, what is that, 33? Now look at the proportion. It's just smacking me in the face. 15 matches up with 33. 10 matches up with X. Cross multiply. Quick solution. X is 22. I'm just telling you, split them up. Play again. Small triangle, big triangle. They want to find the length of MV. So small triangle, X is here. Ooh, that whole thing's 49. If I get rid of the 14, I know this is 35. And the long side here is certainly not 8. I'm going to have to call that 8 plus x. I am going to have to get this involved here. Again, proportions yelling at me. X compares to x plus 8 as 35 compares to 49. Cross multiply over and over and over. 35 times 8, because I'm distributing, it's 280. Move the 35 over there through subtraction. That means I'm left with what? 14. X equals 280. Divide both sides by 14, and x is going to be 20. So we get to play one last time here. Small triangle, 6, 8. Big triangle, x, and that's going to be 20 plus 8. X compares to 6 as 28 compares to 8. Cross multiply, I got 8 times x, and 6 times 28 is 168. Divide both sides by 8. X is 21. All right, the plan for an office uses a scale of 1 square. Each one of these squares is 12 feet. Find the actual length of the following walls. So AB, if each one of these is 12, all right, I got 1, 2, 3 squares. 12 times 3 is 36 feet. BC, that's actually 8 of the squares. 8 times 12, 96 feet. CD's 10. 10 times 12 is 120 feet. EF is 5. 5 times 12 is 60 feet. Okay. Here, this one, we don't have all the same unit in each quantity. So I'm going to take all of these and convert them to inches. There's 12 inches to every foot. So that's 60 inches. I'm going to call this guy 69 inches. Cast a shadow, so 6 times 12 is 72. This is 78 inches. All right, at the same time, a tree casts a 50-foot. Where's the height of the tree? As long as these two are in the same units, I'll be fine. 69-inch tall person compared to, I don't know about the tree. And then let's compare the shadows. 78-inch shadow divided by 50. Cross multiply, I got 78 times x. 69 times 50 is 3,450. Divide both sides by 78. And my tree is about 44.2 feet tall. Okay. I believe this is our last page. We're doing great. An artist makes a scale drawing of a new lion enclosure at a zoo. The scale is 1 inch to 25 feet. On the scale drawing, the length of the enclosure is 7/14. That's just 0.5 inches. What is the actual length of the lion enclosure? X. So if we cross multiply, I just get 1x. A half times 25 is 12.5 feet. Not bad. Under dilation, A becomes here. Now remember, dilations, the way we do it is through a scale factor. This means that all we're doing is multiplying. The question is, what do I need to multiply -2 by to get -8? Sounds like 4, but let's keep trying. What's 3 times 4? Good, 12. If I multiply both of those by 4, do I get this? I do. If I multiply both of these by 4, do I get that? I'm doing great. All right, we just got to make sure we're going from here to here. So what is the scale factor? 4. Make sure because if we were going from here to here, we would be dividing by 4, so we would change that scale factor to 1 over 4. So make sure you know which direction you're going. Because like here, we're going, figure A is dilated, so we're going from the big object to the smaller. So this scale factor better be between 0 and 1 in order to make the object smaller. Okay? Determine the scale factor. So I know that 8 matches up with 4. So what do I have to multiply 28 by to get 4? This is a simple little equation I can solve. Divide by 28 on both sides and reduce. That reduces to 1/7. Well, what's 1/7 of 21? It is 3. 1/7 of 84 is 12. My scale factor is 1/7. So if I want to find x, I got to find what's 1/7 of 91. So 91 times 1 divided by 7, or 91 divided by 7, I get 13. Okay, now I got this. Now we're on a graph. We want to actually do a dilation. We have a scale factor of 1/3. That means we just need to find all of these points. So I'm going to I got A, B, C, and D. Let's find the coordinates. A is at 324. B is at 24, 36. C is at 12, 15. D is at 12, 24. All I need to do, if I want to find their image, just multiply everything by 1/3, which is the same thing as dividing everything by 3. So A better end up at 1, 8. Divide 3 by 3, I get 1. 24 divided by 3 is 8. Then if I just go graph, it's best to do it this way. Then I don't get confused on the graph. I just multiplied everything here by 1/3. Calculator will help you do that. So if I go to 1, 8, 8, 12, 4, 5, and 4, 8. And make sure you connect the right dots. Should be the exact same shape. Just everything's been multiplied by 1/3. Turns out it's going to be like 1/9 smaller, but we'll talk about that at another point. Again, don't be afraid to go back and pause, rewind, replay. Email me if you have questions or if you found that I made a mistake. That's possible. All right. Good luck, kids.